Hello, welcome back to the channel. So let's do another example on calculation of definite integrals using indefinite integrals. So this is a continuation of the previous video. So if you have not watched the previous video, I would highly suggest you to first watch that video in order to get the full context of this video. So we'll use the same concepts, we'll use indefinite integrals and we'll use the fundamental theorem of calculus in order to solve this expression. And we know that in order to solve this expression, we first have to calculate capital F of x, and the capital F of x is basically the integral of my function, right? The integral of this function, the indefinite integral of this function, which is 1 upon 1 plus x square dx. And now let's go back to the chart again and identify the integral of this function. So if we go over the chart again, since our function is 1 over 1 plus x square, we can clearly see that this is the integral of, like if we integrate 1 upon 1 plus x square, we get arc tan x plus c, which is also tan inverse x plus c. You can write either way around. So I'll write tan inverse x because it's more familiar to us instead of arc tan x, but arc tan x is again tan inverse x, right? So based on the chart, we know that this is tan inverse x plus c. And again, please don't miss out the constant of integration. So now we have the definite integral of that function. Now in order to solve this expression, the expression over here, I'll write the expression again, which is 1 upon 1 plus x square dx. It's from minus 2 to 2, right? And you can also identify one more thing in this question. If you watched my video on even and odd functions, you'll clearly notice that this function over here is an even function. So I can simplify this expression. If I have to, I can simplify this expression as 2 times 0 to 2, 1 upon 1 plus x square dx. So it doesn't matter if you calculate this side or this side, your answer will exactly be the same. And we can confirm this at the end as well. So let's evaluate this expression because it seems to be a bit easier than this expression, right? But at last we'll cover both of those sides and confirm that the answer is indeed true because this is an even function. So now we know that we have to calculate integral 1 upon 1 plus x square dx 0 to 2, and we'll do twice of it at the end in order to calculate the final answer, right? So it would be simply capital F of 2 minus capital F of 0, right? And in this case it would be, since our original function, the capital F of x in this case is tan inverse x plus c, let's substitute x based on all those x values. So first value is x equals 2, so it would be tan inverse 2 plus c, and we are subtracting tan inverse, in this case x is 0, tan inverse 0 plus c again. And again, as you already know, the constant of integration will get cancelled out because we are doing a definite integral and it always gets cancelled out when you're calculating a definite integral. So the final expression would be tan inverse 2 minus plus c, minus tan inverse 0 minus c. So this c gets cancelled out. You also know that tan inverse 0 is 0. So the final answer would be tan inverse 2, but since on the right hand side we had twice this integral, so the final expression, the final answer to the question would be twice of tan inverse 2, right? And now let's calculate the expression on the left hand side as well. So if we want to calculate the expression on the left hand side, it would basically be calculating capital F of 2 minus capital F of minus 2, right? And since our original function is tan inverse x plus c, let's do the same process for this one. Now if we do this, you'll notice that this is tan inverse 2 plus c minus tan inverse minus 2 plus c, right? Now let's subtract this out. Tan inverse 2 plus c minus tan inverse minus 2 minus c. So this c would get cancelled out, and we also know one more property of tan inverse functions, that tan inverse of minus x is equal to minus of tan inverse x. This is from the property of tan inverse and sine inverse functions as well. So now if we simplify this expression again, it would become tan inverse of 2 minus of tan inverse 2, right? Because tan inverse minus 2 would be minus of tan inverse 2. Let's subtract this out. Tan inverse 2 minus minus will become plus tan inverse 2. And you'll see again, you'll notice one more thing. This answer is 2 tan inverse 2, and this answer that we calculated by following the right hand side is also 2 tan inverse 2, right? And that is only because 1 upon 1 plus x square is an even function. So you can, doesn't matter if you evaluate the left hand side or you evaluate the right hand side, they will always be equal. So in this video, unknowingly we covered two important concepts of definite integrals. I hope you found this video interesting. In the next video, we'll be covering a more complex example, so stay tuned for that as well. Feel free to comment down in this video if you have any doubts. Follow the channel in order to get notified about the other videos that I'll be uploading. Thank you so much for watching. Bye bye. Take care.